The Homes Verification Program has allowed homes to be qualified to a technology readiness level of 5, which means that the verification consists of component demonstration in the relevant environment. The following tests were completed to verify the functionality of homes within the expected environment of the lunar habitat and demonstrate long-term survival through the possible extremes of use.
Here you can see an instance of the mechanical load test being conducted. This test was performed to ensure that homes can withstand astronauts standing and walking on the panels. The spherical loading consisted of a rounded point load being applied to the center of the top face of a fully constructed homes panel while being supported by a plate along the opposing bottom face. The test required precise data acquisition to determine the point of mechanical and electrical failure of homes. During the test, failure was determined by monitoring the continuity of EDS circuit board traces with respect to the applied point load. Any discontinuities in critical circuit board traces constituted a failure. A load of 441 newtons was tested, which accounts for the maximum weight of an astronaut standing on the panel while carrying up to 82 kilograms. Holmes passed the load test for 443 newtons sustained for 20 seconds. The random vibration test was conducted to ensure that Holmes meets NASA's minimum workmanship criteria for electrical, electronic, and electromechanical components weighing less than 50 kilograms. This test can identify latent defects and manufacturing flaws in hardware at the component level. The test was conducted by attaching one Holmes panel to 2 square tubes. The tubes were attached to a shaker table in 3 orthogonal orientations to test the ability of Holmes to withstand random vibration along 3 orthogonal axes. The functionality of the panel was evaluated before and after the test. Holmes passed the PVTR-7 standard for this test.
The impact test simulates a situation where a point load is applied to homes. For example, if a rock was stuck in the boot of an astronaut while stepping on the panel. To conduct this test, a rounded impactor was dropped onto the EDS PCB from various heights, and the continuity across the EDS electrodes was measured. From this testing, it was determined that the integrity of the panel was maintained up to a drop height of 75 centimeters with a 5.4 kilogram impactor, which is equivalent to a 100 kilogram astronaut impacting homes from a height of 25 centimeters in lunar gravity.
The purpose of the long-term effectiveness test is to verify that the electronics will be able to run for Holmes' expected lifespan of 15 to 30 years. The electronics are repeatedly started up and shut down in a continuous cycle for 12 days in order to perform accelerated life testing. We're conducting this test over 2 fully operable Holmes panels to also test the longevity of the modular electronic connections. We conduct 3 30-second cycles per day, and after every 3 days, we conduct a dust verification test. We have constructed a simple rig so that each time we run a dust verification test, the rate of falling, quantity, and distribution of the lunar dust simulant remains relatively constant with each test. A camera attached to the rig qualitatively records the rate at which dust is being pushed off the panels after every 3 days. You just saw one such run being conducted. We'll be repeating this procedure until the presentation submission deadline. This demonstration shows the functioning magnetized connections between the modular panels.
Right now, you're looking at a full Holmes test, with 3 connected panels sharing common signals and transporting dust on different boards. Lunar dust simulant was poured on the EDS PCBs, and 2 switches on the electronics box were turned on. We then observed the rapid monodirectional movement of dust across the EDS board. In fact, all of the lunar dust simulant was removed from the surface in a matter of seconds. These results are incredibly promising, as the panels were able to work together to move dust at right angles into the collection panel. Thus, the dust was removed cleanly, quickly, and thoroughly.